All right, we're back at it. It's time to really take an in-depth look at slope. And we've alluded to it in a number of other videos. But now I really kind of want to take a deeper dive into slope. So before we do, let's get through what is the technical definition, okay? I'll zoom in a little bit. Oh, sorry. Chapter 3, Section 6. Okay. Slope is defined as the change in y values. Now, change in y values, what we use for change is the Greek letter delta. It's just a triangle. So change in y values is what we call delta y, divided by, or sometimes we say or over, the change in x values, which we call delta x, between any 2 points. So slope is defined as the change in y values over the change in x values. So what I've done is I have put a line, we're going to call this line L, on a coordinate plane. We're just focused on the first quadrant, but everything we're doing still applies. And we want to find the slope of line L. Well, let's pick a couple points. We'll pick that point there and that point there. We'll say that this is point A, and it is at 4, 4. And this is point B, and we'll say that's at, what is that, 6, 5, if I can count right. And we want to find the slope. Now, slope is usually the m variable. So when you see an m, we're talking about the slope. And if I put m parenthesis ab, this is asking for the slope from A to B. So this is slope from A to B. Now, you're familiar with slope as rise over run. That is a concept we're all pretty familiar with. Now, if you think about it, rise happens on the y-axis. So that is the change in y values over, and run happens along the x-axis. So we call that the change in x. Okay, and now using delta y and delta x, we can rewrite this as delta y over delta x. So the slope from A to B is the change in y over the change in x. Where's my straight edge? So let's talk about the change in y first. Well, as it goes from A to B, it slides up and down the y-axis. And this distance over here is that change. All right, so it's going from 4 to 5. So the change here, the delta y, is 5 minus 4, which equals 1. So my delta y equals 1. And then we can talk about the delta x, which is on the x-axis. That's the run part. So that's going on here. So that's delta x, and it's going from 6 to 4. So we can say that the change there is 6 minus 4, which is 2. So I can put that in for delta x, 2. So the slope of this line, the rise over the run, is 1 over 2. And if you go back to what you learned in previous classes, you can see that we have a rise of 1 and a run of 2, or slope of 1/2. What I'd like to do is generalize this concept and take out the numbers, okay? So we have this graph. We're going to take away the numbers. But what we want to do is we want to find a couple points. So I'll pick that point and I'll pick that. And you'll notice they aren't on the graph paper at all. So we're just going to call this point number 2. So this will be x sub 2, y sub 2. So these are just the 2's, or down here if you like. This is x sub 1, y sub 1. It's just to differentiate between the two different x values and the two different y values. Okay? Doesn't mean anything mathematical. It's not like being squared. It's just a name delineation. Okay. Now, the change in the y values is happening on the on the y-axis. But this time we don't have numbers. So what we're going to do is we're just going to say, this is y sub 2, y sub 1. We're just going to say that the change delta y is y sub 2 minus y sub 1. Okay? On the x, bring this down. The delta x is this change. So delta x equals, and we got x sub 2, x sub 1. We got x sub, no, why did I square those? Sorry, x sub 1, x sub 2, x sub 2 minus x sub 1. Go back to the formula where we're using m as the variable for slope. Okay. We can say that the slope from A to B, we know is rise over run. Well, my rise is this bit over here, and my run is this bit. So slope, m, equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. That is the equation for slope, and it's extremely important that you memorize this, okay? More importantly, understand it. Understand the concept, and you don't have to memorize it. Because if you think about it, it's just rise over run. It's change in y over change in x. Understand the concept, and you don't have to memorize the formula, okay? And all we're talking about is the steepness of the line. Okay, let's take a look at something here. I've got example Catwoman. Okay, oh, that's not example Catwoman. Here's example Catwoman. Okay, we're going to use that formula. And it says find the slope from C to D if C is at 2, 3 and D is at 20, 33. Well, always start with the general form. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay? Then go up here and identify one of these as 0.1 and the other as 0.2. Doesn't matter which. I'm going to let this be x1 and this be y1. Let this be x2 and let this be y2. Now I'm going to plug these 4 points in here. Let me stop though. Always write the general form and always identify your variables. It's going to help you from it's going to keep you from making a mistake, we hope. Y sub 2 is 33 minus y sub 1 is 3 over x sub 2 is 20 minus x sub 1 is 2. So you've got 30 over 18, which we all know we can reduce by dividing everything by 6s. We've got 5 over 3. So the slope of any line plotted between these 2 points is exactly 5 over 3. Rise of 5, a run of 3. Okay? Let's talk about Wonder Woman here. Now we're going to use the same formula, but we're going to use it a little bit differently. Now, I'm going to tell you what the slope is ahead of time. So the slope from A to B is a half. Point A is at 4, 2, and point B is at 12K. What we're going to do is we're going to use all this information to find out what is that K value that would go in there so that we had a slope of 1/2. And again, we're going to start with that general equation. M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now, we have the slope. That's right there. Here we've got x1, y1, x2, y2. Now, we could have switched those. This could have been x1, y1, and this could have been x2, y2. Okay, as long as the 1s are together and the 2s are together. You can switch those back and forth. Now, let's put all that information in. Okay, so the slope is 1/2. equals y sub 2 is k minus y sub 1 is 2 over x sub 2 is 12 minus x sub 1, which is 4. Well, we're going to simplify where we can. We've got 1/2 equals k minus 2 over 8, okay? Now this is going to become, now we've got a couple different ways we can solve this. We could cross multiply, or we could multiply both sides by 8. Let's go ahead and we're going to multiply both sides by 8. So times 8 here, times 8 here. 8 times 1/2 is 4 equals, this 8 cancels with that 8, and we have k minus 2. Add 2 to both sides, and you get k equals 6. So if k right there had a value of 6, these 2 points would create that slope. Does that make sense? And if you have to, rewind the video, go through that again. This time, don't try and take notes, just follow the logic, okay? Now, lines come in a couple different ways. One is with a positive slope. Now, a line that looks like this, where it goes from lower left to upper right, that's what we call a positive slope. And then a negative slope looks like this. And where it goes from upper left to lower right. This is a negative slope. And by that, what we mean is if you calculated the value, it would be a positive number on this side. And if you calculated the value here, it would have a negative value. Okay? So positive value, negative value. And there you go. There's your introduction to slopes. We did an example with numbers to just try and get the hang of it, and then we generalized it, and it's through doing this generalization that we actually came up with the formula for slope. Then we took that formula, we saw how to use it between two known points, we also saw how to use it with an unknown value, as long as you know the